Okay, so AC generator. So AC generator converts mechanical energy to electrical energy. Converts mechanical energy to electrical. Mechanical means the coil has to rotate. Here the coil is rotating in clockwise direction about imaginary line. Okay, so what are the parts of AC generator here? Magnet, simple AC generator we am talking about. Okay, it is simple AC generator. So part is a coil which has to rotate. Okay, and how do we rotate the coil? By means of a turbine. It will be attached to a turbine by means of a shaft. Okay, there will be shaft attached to the turbine, and turbine when it moves, the this coil also rotates. What are the other parts? We have a magnets, coil. Beside this, we have rings, slip rings, carbon brushes. Okay, so how will this be attached to this slip rings? Let me take a little thicker pencil. So this is attached to, there are two slip rings are needed here. Carbon brushes also two. And slip rings will be attached to each side of the coil. And see, there is no source of EMF. EMF will be induced due to the rotation of coil in the magnetic field. So I will change the color here. So this is attached to okay. And this one also has a ring attached to it. They should have common axis. Okay, rings should have common axis. So another ring, this one is red in color. For the other one, I will take another color. Say blue. Okay. See, blue one is not attached to this other side. It is attached to this side. It is this red, the one which is attached to red color, it is just passing through this. Okay, but there is no contact. Blue one is attached to this second one. I will label the sides. Okay. They should have common axis, and size will also be same. Mine size are a little bit different here, but they will be same size. Okay. And there will be two carbon brushes. I'm labeling, suppose this is side A, this is side B, C and D. AB is attached to red ring, you may call it ring X or ring P. Okay, and CD is attached to ring Q. And there are two carbon brushes. Carbon brushes are just touching them. There is another carbon brush attached to this. And this is connected to, say, some load or bulb here. The bulb will glow when this rotates. There is no source of EMF. So what happens actually? Let us apply Fleming's. It means this side is moving in upward direction. Yes, second one is going through the, second one is not going through the red one. It is passing through the blue one and it is attached to red. And the side CD is attached to blue. Okay, and this can rotate also about the same axis. The axis will be common, means this is the common imaginary axis about which the rings rotate. When coil rotates, the rings will also rotate along with this. Okay, because what will be the direction of motion of side AB? Side AB is moving up and side CD is moving down. Okay, so what will be the direction of induced current if you apply Fleming's left hand rule, right hand rule to side AB? Motion thumb up and feel towards this. Difficult to apply the rule here. According to this. So motion up inward, A to B. Are you getting current A to B, induced current, if you apply Fleming's right hand rule? Thumb should point out upwards and first finger should point out from north to south. So A to B, this is the direction of induced current. Okay, then it flows this way from B to C. Now apply Fleming's right hand rule to side CD. Side CD is down, so current outward. Are you getting side CD current in this direction? Okay. Yes, C to D, this way the current will flow. It will come towards the slip ring Q, then carbon brush X. Okay, then it will, this is carbon brush Y. Then current goes through the bulb in this direction. Sorry, I should take red color. So this way, there's a complete path. Carbon brush Y, slip rings, they are made up of copper. Okay, they conduct. So through this, see, the path of the current is complete. Right? So what will happen after the coil rotates 90 degrees? The coil will be vertical. Coil will be of this, this part, is this part clear? The path of the current? Okay, so of which, through which carbon brush the current is coming out? Carbon brush X or Y? Because this part is not seen. We this part to see the carbon brush through which, yes. So X will be positive and Y will be negative. It's like positive terminal of the battery and this is negative terminal of the battery, right? Then coil becomes vertical. So here field lines are in this direction. Let me draw field lines. And motion of the coil cuts the field lines. So EMF is maximum in this condition. In this position of the coil, induced EMF is maximum because it cuts maximum field lines while moving up. I will show the video as well. Then the coil becomes vertical, and when the coil becomes vertical, what will be the situation? Let me go to other. Same. We will have north and south. but the coil now is vertical, like this. AB has come here up, CD down. Okay, C and D. AB was connected to red color ring and CD was connected to blue color ring. They will remain connected. Like in DC motor, what happens? The connections to the rings, split commutator, the connection changes. The carbon brush X will remain connected to brush X was connected to blue ring, blue or ring, okay, and brush Y was connected to red ring. So they will remain connected to those respective rings. So here, this is and here this is blue. Brush X and this is brush Y and here is a bulb. So now when the coil becomes vertical, you will notice that the motion of the coil, how the coil is going this way. Motion of the coil now, side AB is parallel to the field lines and side CD is anti-parallel to the field lines. See, this is the direction of field lines. So no flux is cut for a very short period of time. So EMF will be not be induced at that time. Okay, because right now there is no flux being cut. So no EMF. In the previous one, the coil was cutting maximum flux. So EMF was maximum. So if you draw the graph of EMF versus time, so at this point, EMF is maximum and it decreases gradually. And then when the coil is vertical, EMF becomes 0 here. This is T. So here, when the coil is vertical, here the coil is horizontal, this position. Okay, this thing shows this position. Okay, and this point shows, this is figure 1, this is figure 2, where the EMF is 0. Why EMF is 0? Because the motion of the coil does not cut any flux right now. Then coil tilts, okay, then it starts cutting some of the flux, so EMF will be there. Okay, it will be their EMF will be induced, but the direction will reverse. I will tell you why the direction reverses. And then finally what happens? Coil becomes horizontal. AB comes to this south side and CD comes to north side. What will be the position? I will take the copy of this and I will paste it in the other window. Okay. Now I will change some labeling. This side CD has come here after half cycle. That means half cycle is completed. When coil again becomes horizontal, then half cycle is completed. From horizontal to vertical, quarter cycle. When AB goes to the top, like in second figure, this was quarter cycle. This is quarter cycle, 90 degrees rotation is completed. When the its EMF is 0, yes, because it does not cut the flux. Okay, flux does not change to the coil, but that is for a very short period of time, and soon the coil is tilted and starts cutting the flux. Like it will be tilted like this. Now there will be some angle. Okay, now there will be some flux being cut by the coil when it tilts. Okay, during the rotation. So this is 90-degree rotation. You can say quarter cycle. Okay, that graph, if you see that graph, is this that first? No, third one, yes, third one, yes. See here, this is quarter cycle. Now, after this, the coil again, and when the coil was like in the at a position which was in between 0 and 90, like tilted was position, this one, there will be some EMF induced. Okay, and then when finally the coil becomes horizontal again with side AB, CD here. Sorry, this is C, and this is D, and this is A, and this is B. Now B has come to this side, and CD have gone to this side. So this is 180-degree rotation. Again, EMF is maximum, but the direction is reversed. Why the direction is reversed? Let us see side CD. Now CD will have current in upward direction because CD has come to this side. I'll have to make some changes here. Side CD was connected to blue ring and side AB was connected to red ring. So this change I have to make. Okay, so CD is still here and this is connected to this ring now. The connection to the rings will not change. Okay, this is blue. Now, so how will the current flow? Let us see. CD is going up. So current will be inward if you apply Fleming's right hand rule. Okay, to side CD. CD is now, because motion is in the same direction, clockwise. So now CD is going up. First CD was going down in the first figure, CD is going up. So if you apply Fleming's right hand rule, current will be from D to C. Then C to B. Then now BA is coming down. First figure, AB was going up. Let me show you the first figure. AB was going up, CD was going down. So current was from A to B and C to D. Now in this third figure, now CD is going up and AB is going down. So the direction of force has reversed. So current through side AB is now outward. In the first figure, current was through AB was inward. Now see, from A to B to A, D to C, C to B, B to A. Now it comes to blue ring, then to red ring. It will go this way. Now it will go to red ring. Okay, now it will come to red. Now the path is reversed. Carbon brush Y, then I'll have to erase the path of the current now here. So now it comes out of which ring? Red ring, then carbon brush Y to this bulb, and through the bulb, now it is flowing in the opposite direction. Then it enters brush X. So it comes out now through Y. So Y is now negative. and sorry, positive, and now this is now negative. So this has become negative. Brush X. Now the direction of current through the bulb has reversed. So see, this path is in the opposite direction, negative y-axis. Okay, this is positive y-axis and this is negative y-axis. Then coil will become again, AB is continue, it goes down, and then coil again becomes vertical in this way, like B, A and C, D. Again no flux. So this will be 0. Then the first position will come. What was the first position? This. Again AB will be at the same position and EMF will be maximum and cycle will complete. So we will have complete cycle. Again the coil becomes this. And this, yeah, this will continue. So we will get, you. I showed you AC. I gave you the graph of AC. It's like this. Or you can say start from maximum. This is also correct. Okay, either start from 0 or starts from maximum. Both are correct, depending on how the coil was placed in the beginning. If coil is vertical in the beginning, then EMF in the beginning will be 0. Here in our discussion, the coil was horizontal in the beginning. Okay, so this continues and we get the output and bulb glows.